Hello, our today's topic is radioactivity. Radioactivity. And in this topic, we are going to discuss about a comparison of a alpha, beta, and gamma rays, group displacement theory, and how to calculate isobar alpha, how to calculate beta, and how to make isobars and how to make isotopes. First of all, who discovered radioactivity? Radioactivity has been discovered by Henry Becquerel. Henry Becquerel. What is meant by radio? Radio is a wave. Wave, we can say that invisible wave, because all the waves are invisible. We can't see with the naked eye. Invisible wave. Henry Becquerel. For example, why we should need to study radioactivity? Radioactivity, because such radioactive matters are harmful for us, like alpha rays, like beta rays, and most dangerous one is gamma rays. These are called radioactive matters. What is the SI unit of radioactivity? SI unit, that is Curie. Second point, what the scale we should measure radioactivity, because Curie is the SI unit, and how to measure radioactivity, that is second thing, how to measure radioactivity means measurement or a scale, that is GM counter. GM counter is a scale to measure radioactivity that measure alpha, beta, gamma, and many other rays. Third point, what are the treatment if a person has been affected with the radiation of a gamma rays? What are the treatment? Treatment is iodine. Treatment to treat the person who are affected with the rays is the iodine. Many tablets or medicines available in a medical shop, like potassium iodide. And the fourth point, who discovered artificial radioactivity or man-made radioactivity? Man-made radioactivity, that is Aaron Curie. Aaron Curie has been discovered man-made radioactivity or artificial radioactivity. And the next thing is, what are the things are responsible for radioactivity? Things are responsible for radioactivity. What are the things are responsible for radioactivity? First one is weight of a nucleus. Weight of the nucleus means if a weight of a nucleus has been increased, then it became radioactivity. Like, for example, this is a one more atom, proton and neutron present in a nucleus. If proton increases its weight, then also it's become radioactivity. If neutrons increases its weight, then also became radioactive. But in both of them are increases their weight, then become radioactive. But neutron is has a very high weight, high amount sorry high amount of neutron to produce alpha, beta and gamma rays. And the third point, how we can say this matter or this element is a radioactive. To calculate that, if neutron divided by proton is greater than 1.5, then the element or a matter is a radioactive. Let's take an example. Example is 1H1. How to calculate neutron? To calculate neutron, 1 minus 1 equal to 0, and proton is also 1. Then N by P is equal to 0 by 1, then 0. Then hydrogen is not a radioactive element. Let's take another one example. One more isotopes of isobar of a hydrogen, that is tritium. Let's take a tritium, 1H3. Calculate N. 3 minus 1 is equal to 2. Calculate Ra, radioactive, is equal to N by P. Neutron is 2, and proton is 1. Then we got answer 2. Then we can say that if we got a more than 1.5, N by P is greater than 1 by 5, that means it's a radioactive. Then we can say that tritium, it's a one of isobar of hydrogen, is a radioactive element. Let's take some comparison of alpha, beta and gamma rays. Alpha, beta and gamma rays. Comparison. Alpha, beta and the third one is gamma. In the field of charge, alpha is positive in nature. Alpha has positive charge. Beta is in negative in nature, means beta has negative charge. Positive charge, negative charge. And gamma doesn't have any charge. Second point, in electric field. Alpha is diverge or divergent. Alpha became diverge. Beta also became diverge. and gamma doesn't occur divergent. Doesn't occur divergent. Another thing, that is, in the field of photographic plate, in ancient time photographics, plates are used to take photographic plate. This one for alpha, this one for beta, this one for gamma. Photographic plate. Alpha is effective for photographic plate. Beta is also effective for photographic plate, and gamma doesn't affect. Doesn't effective. Fourth thing, speed. In the field of speed and penetration power. Penetration power. Speed or penetration power of alpha is low, beta is average, and gamma is too high, equal to the 10 to the power 8, 3 into 10 to the power 8. Next thing is nature. How the alpha or beta behaves. Like alpha behaves like a helium. We should understand in isobar and isotope topics how to calculate alpha, how to calculate beta. And beta nature is like electron nature, and gamma is electromagnetic waves. Electromagnetic waves. And the last point is ionization. Ionization to break gas molecules. Ionization is high in alpha, medium in beta, and low in gamma. Means alpha ionization power is too high, so it's break gases molecule. These all are a comparison of alpha, beta, and gamma molecules. Next, we should understand group displacement theory. Group displacement theory or group displacement concept, anything we can say. Group displacement theory. Group displacement theory has been given by Soddy, Pazans, and Russell. Group displacement theory has been given by Soddy, Pazans, and Russell. Three are scientists. Alpha. Alpha behaves like a helium, 2He4, and it's low. Slow. What is beta? Beta behaves like an electron, and it is high. I think you all are confused what is high and what is low. Helium is a nature, electron is a nature. Here we have described. For example, we should take an example of uranium 235. 92 235, uranium 235. We should, high or low means if we should take or reduce a alpha means atomic number has reduced in a 2 in nature and mass is reduced in a 4 in nature. For example, alpha, and the uranium becomes 90 and 231. Again we should take a alpha, then it's became 88 and 227. Here atomic number has been reduced in a 2 in number and mass reduced in a 4 in number, because alpha is behave like a helium molecules, and helium molecules is 2H2 a 2He4, and it's low means it's reducing. Another one, uranium 2 means 86 and 4 means 223. Again uranium 84 and 219. Again uranium 82 and 215. I think 215, no, 215. Here the reaction was stopped. Why the reaction was stopped means, let's see the periodic table. Here lead is behave like a capillary. Capillary means border between two things. One is the non-radioactive element and the another side is the radioactive element. Lead is a capillary because before lead, thallium is not a radioactive element, but after lead or including lead is a radioactive element. Let's calculate it. Lead here 82 means 82 and 207. Calculate N is equal to 207 minus 82. Then we got the answer is 125. Radioactive element or not. N by P. What is the N value? N value is 125. What is the P value? P value is 82, atomic number. 82. Let's put the calculation. 1 point that's value is 1.6, approx 1.6. Then we know that if N by P value is greater than 1.5, it's a radioactive element. That's why lead is a radioactive element. Here uranium 235, 92U 235, 90U 231, 88U 227, 86U 223. These all are isotopes of uranium 235. Let's take an example of beta. Beta uranium 235 beta. What the beta can do, it's behave like electron, and it's high means it's add one more electron in numerator, means 92 becomes 93, but mass is the same. Mass is the same. Add one more beta, 94 to 35. These all are called isobars. Isomers and isobars. Isomer means changes in atomic number and atomic mass both, but isobar means doesn't change in atomic mass, only changes in atomic number. How should we calculate? These all are, first of all we should write these all are isotopes. These all are isobars. I should give one more question, you should solve it. Uranium 290, 92 uranium 235, uranium 227. Let's calculate how many alpha and how many beta are available in that. Pause the video and calculate it. 1 2 3 4 5. Now I'm going to calculate this. How to calculate? Have one more shortcut trick for that. Step 1. There is a trick. Step 1. How to calculate number of alpha. Number of alpha is equal to difference of weight, or difference between weight. Difference between weight by 4. There is a formula like 235 and 227. 235 minus 227 by 4 means how much difference? I think 8. 8 by 4 means 2. How many alpha is present in that? 2. How to calculate beta? How many beta are available in that? For that we should need to follow step 2. Step 2. Step 2 is draw the equation. Draw the equation. That is uranium 92 235. If 2 alpha, then it's became 88 and 27 here. If we put a 2 more alpha, then it changes in atomic number and atomic mass also. But if we put a beta, only changes in atomic number, because beta behaves like a electron, so that this atomic mass is stable but atomic number is not stable. How many? Like 88. How many beta? How I have given 91. If a question is given 92 and 91, means 92 to 92 and 98. This one is if we got alpha, put alpha, then uranium 227, 88, and I have given 91, 227. How much difference has the between 88 and 91? That is I think 3. Then beta is 3. this one more trick to calculate alpha, and this one more, this all, or today we are discussed about what atomic radioactivity, and next lecture we should discuss about a half-life, and I am going to put a video related to the physics bio also. I think I should put one more video related to physics today. Okay, thank you.